Hello and welcome to Contour Office Hours. Today is March 27th, 2018, 2 p.m. Pacific. We're here live with Dave Cheney in Australia. How's it going, Dave?
Good. How you doing?
Good. So today we're going to be talking about Contour, this new Ingress project we have here at Heptio. And Dave is kind of the mastermind behind writing it. So we're going to learn more about it. Dave, you want to give a quick intro?
Hi. My name is David. Some of you might know me from the Go space, which is where I transitioned. I was a system administrator for a long time. And about 7 or 8 years ago, I transitioned into being an infrastructure architect and that to being a programmer. And so I've worked on a bunch of different container systems. I built a private one. Worked on a Cloud Foundry install. I've worked in a bunch of jobs as an operator and administrator of Kubernetes, and now I'm here at Heptio, and without sounding too grandiose, to achieve my lifelong dream of actually writing components that run on top of Kubernetes rather than being an administrator of it. So Yay. Contour is like, yeah. So that this was kind of like a match well made. That Contour is exactly the expression of the things that I think people should be building on top of Kubernetes, because the goal is to make computers solve some of your problems for you.
Yeah. So this is like one of the things that we talk about a lot in the book that I co-authored with Justin. And like, I feel like I say it at almost every conference I go to. That's like traditional infrastructure operators are now discovering that they're actually software engineers, and they have been the whole time. And we're starting to write like really cool cloud native apps to do infrastructure-y things. So I feel like this is one of those. But yeah, we have a Google Doc that we're working out of for everybody on the call if you would like to join. Also, feel free to ask questions and interrupt us at any time. This is super laid back. And I figured we could just go through the questions and see what happens.
Well, I actually have a little presentation, just to kind of, so the one thing, like, this is the first time we've done office hours. So even though it's not intended to be Dave talks at a computer for an hour, because it's the first one, maybe this is what happens. But I wanted to give a few minutes of background about Contour, more importantly, background of like the idea of what Ingress brings to Kubernetes. Why do we care about this thing? Because in my interactions on the Slack channel, in GitHub issues, there's a range of experiences of people who've are looking for a particular feature that they need from a different Ingress controller, right through to people who have been told, like, so I have to put my web app on Kubernetes, and Ingress is the first word that comes up in the Google search. So really, this is an open space to talk about the broader problem of how do I host web applications on Kubernetes.
Awesome. So you have a presentation. That's awesome.
Okay. Let me see if I can drop the screen. Okay. All right. And if like my voice robot's out or something else like that, I'll leave it to somebody else to tell me that, because I can't really do two things at once. Cool. So yes, again, thank you everyone for the introduction. As I said, this is not supposed to be a product pitch for Contour, or me doing all the talking. Like really, you didn't decide to spend 45 minutes of your life getting a product pitch. If you want a webinar, I'm sure somebody else can help you with that. But really, as I said, this is about engineers and developers who are using Kubernetes. Like, we have a problem we want to solve, not so much about a particular technology. But to come back to my point, like what does an Ingress controller do? I'm going to recognize that there are going to be a range of experiences on this call, and a range of experiences for people who are probably watching outside. So I think it's probably worth giving a little bit of background on what does an Ingress controller do. If you're Northern European, you might recognize this word. It's the German for entrance. And the opposite, the German word for exit, is Ausgang. And it comes from the Latin ingress, which means to step in. And so Ingress controllers are responsible for traffic that comes into your cluster. They're not responsible for like service discovery within your pods, or outgoing proxy or NAT so that you can talk to GitHub or something like that. They're really only interested in bringing traffic in. In this case, bring HTTP style traffic in. Yeah, all the rest of those things, NAT, are basically somebody else's problem. Ingress is really focused on that. How do I bring web traffic into the cluster?
Is it specific to web traffic or is it all types of traffic?
That's a good question. I'll get to that. I'll address that in a few slides because it does come into the question of, so you use Envoy, that's quite a powerful tool, but I'll take that one on notice. And another question which you might have is like, so like I already have Kubernetes deployed on AWS or GKE or Azure or something like that. And I've already got my pods, they're behind a deployment, I have a service object in there. Why can't I just turn on service type load balancer and GKE will just set me up get a public IP and send that traffic in? Same with AWS, you get an ELB. Like what's the difference between Ingress and just having service? So what I thought a way to talk about this is what I somewhat grandiosely called the philosophy of Ingress. Like, that is, you're running this extra component, like you're adding an extra controller. So what are you getting in return? And the simplest way to say this is that a good Ingress controller should, in my mind, take care of like 90% of things that you would have had to deploy, like Apache as a sidecar or Nginx or something like that. And we'll get into what those kind of things are that will force you to, that you just can't put your like Tomcat web app directly on the internet, why you would want to do that. And so there are 4 that I can think of, and maybe the number's bigger. I just picked 4 because it got a bit small on the slide. The first one is basically traffic consolidation. This comes into questions of cost. Like if every service that you deployed into your Kubernetes cluster consumed an ALB, that's going to have a cost. That's going to consume a public IP. Depending on like the number you have, maybe costs are not so important, but you may have security people who want to know, tell me all the ways the traffic is coming in and out of your application. And the more public IPs that your application has, the more kind of like unhappy they're going to get. So one of the ideas of what an Ingress controller provides for you is this notion of consolidation. It's not a single point of failure. Like you set up an ELB, you always get two public names, which you set up with a CNAME. So it's not about kind of creating a single point of failure, but it is about consolidating endpoints of traffic coming into your cluster down to a smaller set. The second one, super important. It's 2018. Everyone's getting hacked. TLS is pretty much mandatory at this stage. I've heard on the grapevine that Chrome is going to start marking non-HTTPS sites as insecure in July. So it's kind of a pretty strong forcing function. Everyone should just be using TLS everywhere. And of course, with projects like Let's Encrypt and kubelego and Cert Manager from Stack, there really isn't like a cost or management overhead component of this. So basically, you should do TLS everywhere. So Ingress controller is a place where you can do that TLS management rather than having to teach your application to handle it, teach Tomcat deployed behind Kubernetes to handle the certificate itself. Like this is much easier. And so on that point, it leads into a third point, which is, okay, I've just said a bunch of things that you don't want to do. You don't want to deploy a sidecar Apache. You don't want to have to change your application to add this enhanced security feature of TLS. And part of that is because that's kind of like one-off bespoke work. Like you write an application, you have to spend some time in the Tomcat docs, you have to figure out the right certificate. Maybe it's not the usual base64 PEM encoded thing, it's like some other special thing. Like that's kind of one-off work, which once you've done, you're never going to recover the time on. An Ingress controller, and specifically the Ingress object in Kubernetes, kind of to some degree provides an abstraction over these kind of base properties that we expect from a reverse proxy. You should be able to talk about host names, basic routes like send the static image traffic to this cluster, send the kind of web application traffic to that cluster, TLS, maybe even some more properties of that in an abstract way that's not tied to anybody's tool. And the last one is what I consider to be table stakes, which is like once you've got a single traffic ingress, like public ID that is going to answer for all these different websites set up, which TLS set up. There might still be some use cases where you might need an Apache or an Nginx in your request flow, like deployed as a sidecar somewhere between your application and the rest of the world to do some kind of housekeeping. And examples of that could be path-based routing. I talked before that, so to give an example, if you just use service, the load balancer talks directly to an ELB, just put your cluster IP directly out on the internet. That's one service. There is no facility to say like all the traffic on that port goes to one place. So if you wanted to put your /admin on something else, or your /ads on a different cluster, you wanted to serve your static images from a different thing that was handling your web application. A really good example, I had one service I ran. We had an upload service that took a lot of time to process the images, so we didn't want that kind of mixed in with the general request flow. So you probably want to do some basic path-based routing. If you've got HTTPS set up, the next thing you want to do is make sure that people can't talk to you on HTTP. You don't want that that man-in-the-middle downgrading of grabbing the request and rewriting it to be HTTP. So one of the mechanisms of that is any request that comes in on port 80, we just send a 301 redirect to send you up to the HTTPS side. And that's something that if you were deploying just behind a service, you would have to handle that manually, again, with bespoke kind of one-off configuration with Apache or Nginx or Cherokee or something like that. And the third one, which is probably aspirational, because it doesn't exist in the Ingress object, but comes back to my idea of like, what is the philosophy of Ingress? If we want this thing to add value to us, I think some form of request rewriting, like that's very, very common in applications that I've worked on that have been running for a long time, that we have a bunch of stale URLs. Someone accidentally prints t-shirts or stickers or marketing material with slight typo in it or something like that. So rather than going into your application, having to do the deployment of it, adding a route into the application, you want some mechanism to do these little fix-ups, like just rewrite like English spelling to American spelling of a word that was just miscommunicated when it was in a product brief or something like that. So I'm going to pause here for a second and open the floor for questions. But I just wanted to kind of get out my philosophy of what an Ingress controller should provide for people. I think Ingress is well on its way to getting this kind of 89% of these cases. I'm sure there will be exceptions, but the more we make them the exception rather than the rule, the more value Ingress creates. And so this is really the philosophy that drives what I want Contour to be. So, okay. Chris or anybody, I'll open the floor for questions.
I'm going to play back a lot of what you just said, just to make sure that myself and folks at home are following along, which basically when I think of Ingress, I think of this high-level abstraction that you talked about, and it sort of takes these basic components, path-based routing, 301 redirects, the HTTP layer stuff that you would normally see in a tool like Apache or Nginx or something. And we just define that declaratively in Kubernetes. And then an Ingress controller is the actual bits of software that would go and sort of like bring this to life, right?
Absolutely. The Ingress object is very much an abstraction of that configuration. And so at the most kind of like high level, Ingress controllers take the abstract configuration you write in your Ingress object and to convert it into whatever particular implementation they use. So the GCE one, the Nginx one, I think there's an Ingress controller for traffic and of course Contour. So our job is really to convert this abstract expression of these are the things that I want into, like, we're experts in the particular tool, we know how to configure it to do that.
Awesome. Okay, I think I'm good on sort of the scope of what Ingress covers and kind of the shape that an Ingress controller would come in. Does anybody else have questions here? Cool. I'd say take it away, Dave, if you got more.
Cool. So that leads us naturally into what is Contour. As I said, there are plenty of other Ingress controllers out there. The GC and Nginx ones are two big examples. I heard someone using traffic from, I think it came out of Yahoo, and also there's Heptio Pilot. And as I said, Contour is Heptio's Ingress controller, and it exists to basically just to fulfill this philosophy that I just described. Like, if you wanted to know what, like, the roadmap for Contour at a high level, that's it. That's what we want to do. So the next thing to talk about is why did we choose Envoy as the foundation? And to be honest, when Kevin and Joe gave me this assignment when I joined last year, this was the bit that was most exciting to me. I mean, I'm excited by writing tools that make Kubernetes more useful for people, but as you'll see, the relationship between Contour and Envoy was certainly the thing that I've enjoyed the most. Like, they just fit. So why do we choose Envoy? Envoy is a reverse proxy, it's more a traffic proxy designed for dynamic configuration. And this idea of dynamic configuration is really the linchpin. I've worked with a bunch of web servers and proxies and squids over the years, and most of them are kind of like configuration file based, like your Apaches, your Nginx. And so the workflow for changing something is change the file, reload. Maybe some of them have like more sophisticated reload facilities, but it's really file, reload. Of the ones that have APIs, Cherokee is an example. I mean, you can consider F5 products or anything with like a CLI to have an API. Envoy is the first project to come along that treats the API as a first-class citizen and stack configuration is secondary. I can't think of any other product that I've worked with that it doesn't treat the API as, well, you have configuration and then you can come along later and maybe make changes by poking it. Envoy is different. And the key to appreciating this difference is that every other server or network appliance I've used thinks of itself as the API server. Like when you SSH to a Cisco router, when you connect to the Cherokee API server, I'm sure something exists in Nginx. I haven't played with Nginx Plus. You're connecting to the server. The application, your proxy, your switch is the server, and you're just the client. Envoy, it's the API client. Envoy calls, not particularly imaginatively, the thing that it gets its configuration from, the management server. And so by default, Envoy doesn't do anything. Like when you start it, it does nothing. It has no listeners, it serves no traffic, it has no configuration. It just waits for configuration to be streamed to it. And I think there's a lot of similarities with Kubernetes here. Think about the kube. It runs pods that match a filter. It doesn't know where those pods come from. It just makes the world on that machine match the desired state that it sees in the API server. Once they stop running, Kubelet doesn't care about them. Something else will take care of it. And this is exactly the same story in Envoy. You stream your configuration to Envoy, and it tries to make its running configuration match what you just told it. It's very similar. And so that's why I'm so excited about doing this project, because they are the way that Envoy thinks about its configuration matches so well to the dynamic nature of Kubernetes. I want to take a quick sidebar to talk about the question which I get asked quite a bit, which is, so Istio and Contour, there's a bunch of other projects which are using Envoy as their data plane. I was going to say Linkerd or Concur, I can't remember off the top of my head. So they're all service meshes, right? Well, I can't speak for the other projects, but Contour only does HTTP ingress. We don't think of ourselves as a service match. We just do HTTP ingress. And this is because Contour is only concerned with what you put inside the ingress document. you might want a feature like TCP forwarding or SSL pass-through or something like that. But if you can't talk about it in the schema of the Ingress object, which is sadly quite limited, then Contour can't help you. This isn't necessarily a Contour or an Envoy limitation. It's widely recognized that the Ingress object is pretty underdeveloped at this point, but that's kind of out of the scope of this call. Like, I really don't want to get into bike shedding the problems with Ingress. We're really just here to use the tools we have available. So the takeaway is that Contour can only configure Envoy to do the things that are described in the Ingress object. And the Ingress object only talks about HTTP. And it leads to the second point, which is even though the Ingress object is quite limited and it's led to this kind of Cambrian explosion of annotations, I didn't finish that point. Looking at my notes, I didn't finish that point. So even though there might be other projects, there might be another project that comes along that builds on Envoy that exposes its TCP features or its MongoDB proxy or things like that. There are already a few in the market. The goal of Contour is to use Envoy to talk about HTTP. So Ingress only talks about HTTP, so Contour just does HTTP. And to go back to my opening philosophy, which is that as much as we can, we want to hit that 80 or 90% case, that otherwise you might have had to break out Apache with Modry, right, to do a little bit of fix up, or something like that. As I said, like we use Envoy to fulfill the goals of Ingress. We probably, like, we're certainly selling Envoy short in terms of its capabilities, but one of the non-goals of Contour is to try to expose all of the features that Envoy can possibly do. That's very much not the goal of Contour. We want to keep it focused on helping Kubernetes users and developers host web applications on Kubernetes. So that's yes, that's the end of the prepared statements I had. So yeah, let's pause for questions and ask questions. You can pretty much ask anything about Contour and more broadly, like about how do you solve the deployment problems or the kind of usage problems of deploying your applications on Kubernetes that need to talk in the HTTP realm. I'm here to give such advice as I can. Okay.
I'm going to do the same thing I just did, which is kind of regurgitating this back to you a little bit to make sure my headspace is right.
Mm-hmm.
So Envoy, similar to the kubelet, and it's like sort of like, for lack of a better term, kind of dumb when it starts up. You then send declaratively which configuration you want to it, and it can then take that configuration, recognize it, and attempt to reconcile its internal state based off of that configuration. And then Contour wraps up Envoy in all of its wonderful declarative goodness and only uses a subset of its features to solve this ingress problem that we talked about in the previous little session we did.
Mm-hmm.
Okay, cool.
So there is a document. A link in the document. I'm just opening another presentation where I have an image I can share. It's called Contour Under the Hood. And so the easiest way to think about, let me just share my screen. So the easiest way to think about the easiest way to think about where Contour fits between Kubernetes and Envoy is that Contour is a translator. We are a client of the Kubernetes API, and Envoy is a client of Contour. The information flow is absolutely one way. There is no bidirectional communication. Contour just watches what happens on the API. Okay, so that was a slight abuse of the truth. Like there is a little bit of flow to Kubernetes, which is updating statuses and events, but probably out of. and Envoy, and so basically when you make a change in Kubernetes, Envoy translates that into the configuration Contour translates that into the configuration that Envoy understands. One interesting thing about the way that Envoy works is that you don't ever send it deltas. You don't ever send it like increase that or remove that or add that. You always send it the complete new state of the world, and Envoy does what it needs to change the running state into the state of the world. It's actually if you talk to Matt Klein, he's very firm on the idea of that everything should be immutable. So basically, when you send Envoy a new configuration, it creates a new world and throws away the old world. So even on the Envoy side, they don't take the running configuration and say, oh, this listener's been removed, I'll turn it off. This route has been added, I'll slot it into the current running configuration. They literally create a new world, connect up the listening sockets to that, and move on with that. And the old worlds kind of age out over time as their connections drop off.
Okay. How does Contour, like what's the interface between Contour and Envoy? How does that transaction get handled?
In the very early days, the interface was REST, which had a bunch of problems. Namely, that if you want to get low latency between a change in Kubernetes and seeing that in your running configuration, which is very important because if you made a change in your Ingress, to step back a little bit, I like to say that debugging problems with Ingress is, but certainly like any external traffic in Kubernetes, is kind of like a murder mystery. Like you go to the pods, it's okay, some pods deployed, that's good. You go to the service object, it's okay, that seems to be all connected up. You go to the Ingress object, you're like, yes, the name of the service, that all matches up. You basically go around the rooms of your deployment looking for the suspect. And so if there was a great delay between doing kube control edit on your Ingress object and those changes actually being replicated down in the running Envoy, that's going to make your debugging significantly harder because you're no longer actually seeing the truth of what is running. So in the very early days, it was based on polling, and so you have to set the polling interval very, very quickly. Otherwise, you have this latency. In all the versions of Contour that people are using at the moment, we now use gRPC, and this gives us the ability to stream configuration, which is in terms of computing instantaneous. Like there is no prepare a thing and wait for somebody to come and pick it up. You just sit in a loop, using gRPC primitives to stream configuration back to Envoy. So the communication between Kubernetes and Contour is the Kubernetes API with your usual watches and things like that, and the communication between Contour and Envoy is gRPC. The gRPC API is fully specified. It's kind of verbose. I think that's how things are in gRPC. But it gives you a lovely typed place to put all of the configuration you want. One of the disadvantages of the previous JSON-based API is there's no schema. Whereas in the gRPC API, like we have a client library on the Contour side provided by the Envoy project themselves. So literally, if there is a place to put the data in, you know that it's going to be properly typed. And when Envoy gets at the other end, there's a very low possibility of schema validation errors. It's not zero. There's some reasons for that, but you can have a high confidence that literally if it fits through the kind of window of the strongly typed gRPC message, it's a valid config.
Awesome. That sounds like whoever wrote Envoy was doing a really good job. Because I kind of now want to go consume it for other things if it's all gRPC and it's super typed schema on the other end.
Yeah, so that there are definitely lots of other things that it's based on this notion of there are 4 primary resource types. Listeners, which are to do with the properties of the listening socket and that socket has TLS. And listeners are connected to, the next one is RDS, which is called routes. And the connection between listeners and routes are this thing called filters, which is this slightly generic connection. But basically, you say this listener is connected to a HTTP manager, and so HTTP managers know things like vhosts and routes, and so they're the thing that connect listeners to routes. And what we think about as routes is that's the closest that we have in Kubernetes to Ingress, like the Ingress document where you say spec, paths, HTTP, and the service name and backend. So routing is really match this, send the traffic to this backend. And the backend is the third object, which Kubernetes calls a cluster and has a very strong analog with, Envoy calls a cluster, has a very strong analog with Kubernetes' idea of a service. So in both, they are the abstract notion of a service. This is a thing that can provide you with service. It can provide you with a HTTP service. And so that's where properties on the Envoy side of things like the load balancer strategy, timeouts, number of upstream connections, all that good stuff that exists on the abstract notion of the service. And the final component is called endpoints, which actually has a good crossover with Kubernetes endpoints, which really, these are so when you have a service that will say these pods the pods matching the service will talk on 8080, and Kubernetes behind the scenes constructs the endpoint document, which gives you for port 8080, here are the IP addresses that will actually talk on that. And so Kubernetes, as deployments and replica sets manage the pods that are running, keeps the endpoint document up to date. And the endpoint document is how we tell Envoy, here are the actual members of your cluster, here are the backend members of your service.
Cool.
And there is, I don't know if I don't have a table of that, but I remember drawing it on a whiteboard for somebody last week. But there's a very nice crossover between there's almost a one-to-one mapping between Kubernetes ideas and the different API types that Envoy has. When I say API types, they are different streams of data that it listens for. So it listens for when Envoy connects to Contour, it opens up a stream and calls fetch listeners, which is literally tell me about all the listeners that I should have open. Same with routes, same with clusters, same with endpoints.
Awesome. This is what Contour has been up to this whole time. That's cool. So you have here HTTP and HTTPS. I'm imagining that means at some point we're doing like a TLS offloading, and some part of the system is managing the TLS aspect, and then we're just passing off plain old HTTP to other parts of the system.
Yes, this was, I was hoping to prepare 2 demos. I didn't get that one done. So Ingress has a way of talking about TLS, as in the certificate you need to use the host names that you expect to answer for in the actual Ingress spec. So this is the abstract notion of this, and you do it in that very Kubernetes way of here is the name of the secret, which you'll find the key and the certain private key that you need. So when you configure Envoy to handle TLS, we need to get those certificates over, and that's handled as part of the listener. So this is where I talk about there's a slight impedance mismatch between Kubernetes and Envoy here, because in Kubernetes, the Ingress document talks both about the names of hosts and TLS properties and things like that, as well as the routes. So there's a little bit of magic that we have to do behind the scenes to, when we get an Ingress document that we see off the, I say document rather than object because unfortunately I'm contaminated with MongoDB and I can't not say that word, but when I hear document or object, just translate as appropriate. So whenever we see an Ingress arrive on the API, we do a little bit of magic to pull it apart into the bits that talk about the virtual host and the bits that talk about the routes. And we stream those separately to Envoy. And that means that Envoy is doing the TLS negotiation for you. It's not necessary. Like you might have, if you're in a larger, I deal a lot with the public cloud, so it's reasonable to put ELBs in TCP mode and just forward that traffic down to whatever needs to handle it. But there are definitely other cases where you want, you might have like a hardware load balancing appliance if you're like in a really big organization that has their own private Kubernetes cluster, in which case the TLS is going to be handled for you before Kubernetes even sees it. So you wouldn't, in that case, talk about TLS. There is another case, which is, suppose you have the service on the back end, which is talking about Kubernetes, like one of your pods in your deployment is actually using HTTPS. And so there are two use cases for that. One, you might live in an environment where you want to have TLS communication everywhere between all the endpoints. If you're not super confident about the security of your internal network, it might just be a policy that you have to do. You might just think it's a good idea. The other one, which is more coming up in the world, is if you're using gRPC. gRPC natively just uses HTTPS for framing. So you have the problem of what is the protocol not between the world and Contour, your Ingress controller, but between the Ingress controller and your backend services that you're deploying in your Kubernetes controller. At the moment, the service object doesn't give us a lot of help there. It will tell you what port it is and what protocol it is, but that's kind of like layer 3. Sometimes you need to say, what is the layer 7 protocol of that? And we've just had a contributor land in the last 2 days. I landed a PR while I was in an airport land in Los Angeles last week, who lets us talk about, it's an annotation on the service document says, this port has this layer 7 protocol. So this port is HTTPS. And that's useful because we can put that information into Envoy's cluster API. And that says, when you talk to the back end of this, don't just open a straight TCP port and just talk to it. You might need to do TLS negotiation on that before you actually start to send traffic. And so that hopefully will unlock backend services that use HTTPS, backend services that use gRPC. That's one that's coming up. We've got some contributions, PRs in the works for that. So there again are unfortunately some bits of the service model in Kubernetes which need a little more help in the form of annotations to be able to talk about what is the actual protocol that my service talks, not just like what's the port and do I talk TCP to it.
Yeah.
So I know that we started a little bit late. We're probably coming in on less than 10 minutes to go. I'm a little cognizant that I've done all the talking. Let's do it like this. If you don't feel like if you're watching this recording afterwards, or you don't really want to ask a question in public, like you can always find me on the Kubernetes Slack. We don't have a mailing list or anything like that. Like it's just a small project, and it's mainly me and a few other Heptonians who are doing the outreach and community management on this. So if you have questions, GitHub issues is the really good place to ask it. If you want to email me, dfc Delta Foxtrot Charlie at heptio.com. And I'm happy to answer questions around this whole space of how do I put my web application on Kubernetes. Like, I'm probably going to tell you a solution that involves Contour because that's what I use. But really, I'm not here to say that. My job is to make you successful by using Kubernetes. So if you have questions like, I can't put my ELB into the right mode, like I can't make HTTPS work with my ELB, or what is the best way to route traffic down to my application? I'm happy to answer all of those types of questions because I'm not here to give you a product pitch.
Awesome. And then when we put this on YouTube, I'll add your email and everything you just said down in the comments too below, so that users can ask, send you an email, ask in the comments, whatever.
Cool.
I think Josh has a question.
Please,
hey Dave,
go for
hey
it.
Chris.
Hey.
Thank you very much for putting this together. Dave, this is an awesome tool. I've just started diving into it, and my question is, how would one go about debugging a failed Ingress creation? So far, I've been able to get Cert Manager up and Contour running, obviously, with both the Contour and Envoy pods. The only thing that I'm getting to actually resolve is the coord example. And when I put my own deployment in place, I cannot get any host representation out of Contour, although there are no logs that are throwing errors. Everything says it is deploying correctly, but then obviously when I go to the endpoint, it's not resolving. So where would I start?
All right, this is an excellent question, and I have I can show you how I go through this. Let me just share my screen. So most of the time, the first thing you probably want to have up is this troubleshooting document, which is there are two ways to get access to. So obviously you can watch Contour for the logs, but really we want to know what Envoy thinks about like the information it's being told. So the first one is you can port forward to a Contour pod. Let me just do that. I already got something listening on that. I will just that's unfortunate. So yeah, a million screens. I'm not really sure which one it is. Okay, so let's just see if I have one that's listening. There's something that's listening. Nope, don't know what that's going to. So I'm going to skip that. I'll prepare a little bit better for this demo. I've got something listening on that port. I don't know what it is. The other one is that we can ask Contour what is the information it's sending to Envoy. Like basically, we want to pretend to be an Envoy and read the information that it's doing. And the previous to 0.4, like this isn't in 0.4. It's only in master. We had a tool called Contour CLI, which I used for debugging, which was just like development on my local machine. Like I run Contour on one screen, and I want to basically ask the local Contour, what is the information that you see? I've just recently moved this into the Docker image. So it's basically a sub command on Contour. And so you SSH, so you exec into your pod and run Contour CLI so that you're in the right, so that you can communicate to Contour over the loopback network. And you can ask it things like, let me just, okay. So this is going to run in one of the Contour containers. It's going to run this command, Contour CLI, and LDS. You have, it's not going to work for me.
Cool.
So you have LDS, RDS, CDS, and EDS. So if you want to look at the listeners, this is the textual version of the. I shouldn't show you listeners because it'll show you my certificate. Well, I won't show you the whole thing. But this is the gRPC message that's sent between Contour and Envoy. So if you're like, why is it not listening on port 8080? Well, if there's no listener here and there's no listener in port 8080, that's why. So that's one debugging thing. CDS gives you information for each cluster. So we have a cluster, it's from the namespace, the name, and the port. And so basically, clusters, which are mentioned in RDS. So route to clusters, and clusters route to services. So you'll have a bunch of endpoints that have the service name default card. So let's look in. Let's try and find. Where can I find my? Yeah, there is. There's the card one there. So where CDS mentioned the cluster name default card, EDS, which contains the endpoints, has the actual port and address. And this one that I have deployed here is a very contrived example because it is possible to have pods from multiple deployments matching the same label that a service expects. So you can actually like have some on different ports as well as different IPs. So to get back to the question, this is the first. If you come onto the Slack or GitHub, I'm going to ask you for things like run this command and does it show up in EDS? If it's in EDS, we're seeing it from the Kubernetes API. If it's in RDS, if it's in CDS, we validated that the document, like it's in the API server, and we've correctly translated it into the gRPC form. The other one, which unfortunately I can't demo at the moment, is looking at the Contour API. And when you go to this, it's the admin interface, which gives you basically a form to like list the routes that it sees, list the clusters that it sees, list the endpoints, and it's basically applying. Now, what I have seen recently in the last week is a bunch of people say, look, it all looks fine on the Contour side, but Envoy just isn't picking this up. It just says no healthy clusters. And what I think is going on, it's certainly one of the things I have to debug this week, is Envoy has this thing called pre-warming. So when you introduce a new endpoint to it, it's not just going to blindly put it in its set of like, yeah, let's just serve traffic from that. It's actually going to send it a dummy request. I'm not exactly sure if maybe just opens a socket and closes it, but it basically checks, like, the thing you just told me, is it right? And this is what it calls pre-warming. And I suspect that what is happening is that these, the configuration is right. The endpoint document points to the port and IP of the endpoint, but something is preventing it getting out of this pre-warming phase. So basically, the configuration is not applied because it doesn't warm properly, and I think that's what we're seeing. But yeah,
is it fair to say that if you see the entry in the log of warming complete, that you've actually navigated that handshake successfully?
Yes. So that would be my next question. Like, do you see that?
Yes.
Okay. Cool. I think did you raise an issue like about a couple of hours ago, and I started responding to, because it might be easier to, rather than debugging this on chat, to we either get on the Kubernetes Slack or or talk about an issue rather than like a public recording.
Sure, fair enough. I joined the Slack channel earlier today. I will review the troubleshooting markdown that you've shared, and if I still run into errors, I'll holler at you on Slack.
Cool. Yeah, but the tools you need are like to port forward to the Envoy API, so that you can like verify the config is applied, because if it's not there and that it hasn't applied it. And the other one is Contour CDS to verify that like what we're sending to Envoy actually matches what you think.
Excellent.
Which it's a slightly confusing issue because I haven't hit it myself, and I deliberately construct these very convoluted deployments to try and test those edge cases. But yeah, it's one that several people have reported yet, but I haven't been able to reproduce it yet.
Excellent. Look forward to chatting with you.
Cool. I'll speak to you online. Let me stop sharing, and I'll hand back to Chris.
Awesome. Yeah, we're, I think, just about out of time.
Okay.
Cool. Well, I'm sure we're going to get a lot of feedback concurrently, so take a lot of that offline and do our best to keep it documented and have a paper trail behind whatever comes out of this.
Cool. Yeah, and I imagine we'll do, if there's good feedback from this, we'll do these in the future, probably at the moment with the team breakdown, probably like a 1 to 2 month cadence, I think, which sort of matches the cadence of Contour. We release every other month. So, but if you need more immediate feedback, please don't wait to hold your question for 2 months. Like, hit us up on the Slack or put it in a GitHub issue, and I'm happy to help.
Yeah, maybe we can do one of these like at KubeCon or something face to face. That way we can actually be in the same room.
Sure. Yeah.
Cool.
All right. Thank you everyone for coming on today. I hope it was useful for you.
Yeah, and Dave, thank you so much for a wonderful presentation. Bye everyone.